thank you for coming back to Mobile London. Good to see a good number of participants again, and seeing familiar names sort of coming up. Today we have a presentation from Genc, Building Apps to Last. So yeah, thanks for him for taking the time out today to do this. With the talk, it's going to be like normal. We'll do questions towards the end. And yeah, we'll go from there, guys. But yeah, like I said, anyone who's just joined now, who I've just accepted in, we're going to do questions at the end. We use the chat box like normal. But yeah, over to gents.
Cool. Great. Hello, everyone. This is Genc. Thanks for being here. And thanks to Tom for organizing this. I would really wish we could just meet in person, you know, just be in the same room, discuss stuff, ask and answer questions. But for now, this is as good as it gets. So thanks again for joining. So I hope you can all see my screen. Just shout out if you can't. So I'm Genc. I'm working at Sky Betting and Gaming at the moment. I'm working on our sports and betting app. It's fun, really. You know, sometimes I just watch horse races, greyhound races for debugging purposes. Not always, but sometimes. I've just started there. Before, I was a contractor for a private bank in London doing mobile applications, banking applications. And then before that, again, I was contracting at so many different companies in the domains. I would really love to connect and be in touch. So if you're interested, please feel free to add me on LinkedIn. So building apps to last, that's what we will be talking about today. I would like to start with a question though. If you had a successful app business, like something profitable, maybe say making like so much money, what would you care most about your apps or generally your business? I mean, if you were having this meeting in person, I would love to get some answers from some of you, but I need to make some assumptions myself for now. So some of these, I guess, would be among the answers, like maybe how the application looks, the UI, UX wise, and how much people love it, the downloads, ratings, reviews, special retention is like, you know, very popular in management level, obviously. And then how well it works, maybe, you know, just how well, you know, just either way to spec and then how good it is. Or high code quality, there are several ways to, you know, just define it, but just maybe that would be the concern. Or maybe the security, you know, just how secure your app is. I mean, I appreciate all these are very important and vast subjects, but the winner is, the king is, if you ask me, is like how maintainable your apps are, right? I mean, how easy it is to make a change and then deliver value to the end user. You know, are your delivery costs increasing by each delivery, or is it stable? That matters most. I mean, because everything else in the list can be done, you know, relatively easily if your app's architecture allows you to do this change. If it doesn't, I mean, if your architecture is not good enough, it doesn't allow you to make change and deliver easily, then the app and the business will basically rot. I mean, no matter how good and profitable it is at any given time. There's one good and public example for this. Not, I mean, good for us as an example, but not that good for them. I mean, it was Tesco. And it's a good example. I worked on Tesco's grocery mobile application in 2015. So I worked on, say, the first version of the app. And then when I joined as a contractor, the app was already in a kind of coma, like, you know, just meaning it was near impossible to refactor it, add new features and deliver in reasonable time. So I was working on a feature offering users 4-hour slots for grocery delivery. And I remember it taking a lot more than it normally should. Like, you know, time means cost, obviously, and then delay wasn't about the technical skills of any of the team members, but the app was simply resisting change. It was hard to add something without risk of, you know, breaking something else or bringing the app to an halt or slowing down. So this is a very interesting article, really. You can read it on Medium. There's this guy called Jack Rolls. I mean, he talks about it. There's one particularly interesting thing. He says the discovery phase of second version alone took 6 months. So just imagine the cost of rewriting all the application. So just if you search, if you're interested, you can see the full article. So as the article says, the day came finally for Tesco. You know, just they took the plunge and version 2 of the app started from scratch, a total rewrite. So we can say, you know, just an app or business is dead when the cost of change is higher than the value provided, right? I mean, that was the case for Tesco, I believe. So the cost of delivery just went through the roof. After some point, it's just unsustainable. It doesn't matter if the business is still profitable with the existing state of the app or not. I mean, if you can't deliver cost efficiently, then you can't compete. And if you can't compete, you basically don't have a business. Just dies off slowly but surely. So the Tesco decided to ditch the old code, and the app, you know, just the app was profitable at this time. It's just a grocery application. It's just making, just money, and everyone were using it. But again, it doesn't matter that much. So numbers here don't belong to Tesco, unfortunately, but it belongs, their actual numbers belongs to an anonymous real company in Fortune 5,500. So as you can see, the cost of just development just skyrockets like by each release, and then after some point it's just not unsustainable. Whereas the productivity just goes down like with each release. It's measured here by the line of codes written. So after like 8th, 7th release, like you can't add anything because whatever you do, it's just touching so many places, and then basically you are done. Okay, so healthy software is expected to last 5 to 7 years, right? Without a major rewrite. That means you can't tell your boss before that time that you need to rewrite all that. I know it's probably everyone's dream to write a software, from scratch, starting over and using the best practices, no bugs, no tech debts for some time at least. Sounds all good, but seriously, when was the last time you saw or worked on an app that lasted that long? In all the companies I worked for, there came a time that we said, or just we had to say, let's move on to version 2. While some unlucky bunch of guys stayed to support the first version until the new one is ready. That's very, very typical, I believe. So we know what matters now. Let's talk about what we do not to be in that situation. So as you may have guessed, what matters most when designing an app to last is architecture. I'm an Android developer at the moment, but I'll try not to be Android specific. The tools, approach, and the patterns we talk here usually apply to other environments too. Sorry. So we have several principles to consider and apply, but I would like to start with the one that I personally think matters most. So it's dependency inversion. The name may not mean much if you're not familiar, but don't worry, I'll just give you a good example. So it's actually an object-oriented programming concept, but the principle is applicable to all levels of software development. I believe even in our daily life, like object-oriented programming is a model based on real life anyway, isn't it? So the formal definition is one module, one piece of code in your application should depend on the contracts and abstractions only, not the concrete implementations of or other pieces of code. So we want to be in a situation, just where implementation details are hidden from those depending on them. So we can easily add, remove, change parts. So just if you see this, just very simple diagram, this module A depends on B, it uses it, just these two different pieces of code. So A uses B, but it doesn't mean that necessarily A is aware of, just how B works. The reason being, when it's time to make a change in module B, it's not if, by the way, it's when you will need to change because, businesses change, needs change. So we'll need to make a change in B. So whenever you make a change in B, you will need to change module A as well because it's just like tightly coupled to it. It just uses it. And then when you make a change in A, maybe there's another module that like C, D, it depends on A. And then just like this way, cascadingly it goes up and up. Like at some point, you change something even very small, then it just touches so many places. So how do we do this? How do we do this? Not to be in this situation, we break the dependencies by introducing the contracts. So the logic here is, I'll tell you what contract is, but the logic here is the implementation changed, but the contracts are unlikely to change, at least not as fast as the implementations. So contracts are our businesses, right? They don't easily change. So Sky Bet and gaming, for example, our contracts are like about bets, sports, horse races, football, just how things work. People place bets, there's a sport event, this won't change. So I would like to, just go through this simple application, simple example, how it works. Like say this is our coffee addict, right? And then he needs some coffee, sugar, and maybe milk. So we have coffee providers here at the bottom. Imagine them as the concrete implementations in the code, because this is what they do. They provide actual coffee, actual implementation. Now the provider's implementations are abstracted from the addict. He doesn't know or understand where the coffee is coming from thanks to this middle layer here, the contract, right? All he knows is just he gets some coffee. He doesn't even see these providers. This gives us, our business, the flexibility to change the provider at any time without any concerns to our client. So the first week we can serve Starbucks coffee, right? The next week, if we get a better deal, we can just get copy from Nero. All we need to do is just to change the integration code on this side of the contract. We don't touch the edit class, and the edit just doesn't even know, what's going on. That's all matters. So here again, very simple diagram that this object A directly again depends on object B. That's what we don't want. What we want is to go from this to something like this. This is how we do dependency inversion. As you can see, this dependency is just this direction from A to B. But in this model, I will just quickly show how it works. But we just introduce this contract here, and then all object A knows is this contract, and it just uses it. It doesn't know anything about object B, whereas object B is just a provider of this contract. Contract. It just implements it. That means whatever you change in object B, as long as you keep your contract same, the object A, you don't need to touch it. And if you don't touch object A, then just the change stops in this object B. So that's what we are trying to achieve, right? So let's see some code. I mean, it will be a bit high level, but so let's see. So this is I'll just change this, refactor this to a proper design. So this is the wrong design. So as you can see here, we have this coffee edit that we talked about. So it has direct access to this coffee, sugar, and milk. So it creates them, these objects, and it uses them. It just tightly depends on them. If you make a change in the copy, you change the coffee edit, and if you change it, just God knows what else changes. That's what we are trying to avoid. I mean, they may look simple, but this is really the main reason why apps and generally software works. Like, you come to a point that you can't change anything just because of that. I mean, that's the point that you go to your boss and say that, hey, the feature you're asking, it will take 1 month. I mean, maybe he was expecting 3 days, and he just doesn't get it. Or you say, you know what, we better rewrite this. And this is also QA, just comes and say that, the estimation to test this little change is just 1 week, because like you'll be testing a lot of other places. So to fix it, what we do, this is the fixed version, this simple change, like generally it saves our lives. So instead of creating these classes ourselves, just making it tightly coupled, we provide our coffee edit coffee contract, right? And then the contract, all I mean is just like this simple interface here. It just says, it defines these 3 methods. We don't know who provides them yet, but you just provided it. And then all this coffee edit does is just gets this coffee, milk, sugar, and then it does whatever it does with them. So it doesn't know who provides these coffees. That's the whole point. It doesn't know who is just providing this, who just implements these methods. So one day we can just come up with this, Starbucks implementing this contract, and then they are providing their own milk, coffee, sugar. Then next day, as I said, it can be anything else. Then this can change, and then we wouldn't need to touch any part of this. This is what saves our lives. Okay. So dependency inversion is the principle, and then dependency injection is the pattern. It's just one way of achieving this goal. There are some other ways, but I'll just quickly mention these 3 here. So dependency injection patterns in Android. So on Android, we have a few ways of achieving this, like Hilt, Dagger 2, and Coin. There are some other frameworks, but these 3 are the popular ones. So the Dagger is the pain guy, actually. I mean, if you, I'm sure you experienced it firsthand if you tried it before. It's still very popular. It's probably the vast majority of apps are still using it, and will be using it in the near future. And then Hilt is the new dependency injection framework built on top of Dagger. It's easier to understand and manage. So if you're starting a new project, I would definitely recommend to go with it. And then I have introductory article and samples on Medium as well, if you're interested. Coin is the third-party solution. It's much easier and developer-friendly. I use it for just all my personal projects, so just give it a go if you are just starting. Okay, a bit more real-life scenario. So in almost all mobile applications, we have these layers, right? The presentation layer is where the interaction happens with the user. Just drags, drops, touches, fillings, and this is where we display the data to user as well. And the business layer, the use cases are on domain-specific code. They could be like using a third-party framework or services, or require some work, just done at another level. Then we have our data layer, obviously, needs some data provider. And then these are the obvious places, these question marks, that we introduce our, just the contracts interfaces, so that, just we are not tightly bound to the, just this implementation specifics. So this is one major mistake I see all the time, wherever I work at, the specific implementations done too early in the architectural design, right? I hear developers or people in management talking oh, just which database are we going to use, which services we'll be using, even like which input method we will be using, like soft keyboard or voice input. I mean, the thing is that these questions should not matter. They are like irrelevant to me. They are usually asked way too early in the architectural design process. These decisions must be delayed as much as possible. Like for the architecture of the app, it shouldn't matter at all if you are using a database or not. Just put a flat file there, a JSON file maybe, and you should be able to continue building your system, like maybe till to the end of it, like much later, maybe towards the end of the project. You can introduce it any database, replace the flat file, and everything should keep working as it is. If you can do this, this is a very good indication that just your system is stable, maintainable, and it's like architectural wise, it's good. I mean, a good test for you to answer just that question, like if you had like imagine that you have a mobile application developed, and I ask this in interviews as well that I do. Like imagine you have a mobile application developed, and I ask you to completely change the environment that it's working on. So instead of a mobile application, if I ask you to run it as a console app on a Windows machine, like what percentage of code would you need to rewrite? I mean, the answer to this question is foremost is 100%. Yeah, you just say that just I wrote it as a mobile application. There's no way I can just port it to another environment. But like in an ideal world, you should be able to, because like if you could abstract your use cases and then there's some core classes, from the environment that it's working in, then you should be able to port some code to another, like to web or as a console application. You can just, you should be able to do it, like instead of using an SQLite, say on Android, the device database. If I provide you a list of comma separated values, for example, it should just work. It shouldn't matter that much. All you would need to just change the drivers and accessing these resources, and it should be really done. So if the answer is no, again, as I said, this indicates a problem. Like ideally, you will need to, you should be able to do that really, but that never happens, right? Okay, so what we do to ensure that we have this, just stable application that just very loosely coupled. So there's clean architecture is one way. It's just one approach. I mean, we can talk about it all day, but basically, it's an approach that is a set of rules about designing our application in a layered way that the outer layers depend on the inner layers. So there's one direction of dependency, and it has to be one way, meaning no inner layer can know or depend on anything on the outer level. I mean, if you're hearing this for the first time, it may be a bit confusing, but I'll just try to explain it. It still serves the principle that we discussed earlier, like loosely coupled modules, so that they can be changed without breaking each other. For example, this is a very basic example, but very typical in many Android applications. So we used to, like years ago, we used to develop like monolithic apps where all the code and modules stay in one single place. But this approach you see here, just gives us a more maintainable app. As you can see, we have 4 modules here. We have application where all Android specific code stays. Then we have data, domain, util, and I'll just quickly show you how the dependency works. So this is from real application, by the way, that I'm working on. So in this application, just the inner layer is the utilities, like things everything depends on, and then this util doesn't depend on anything. I mean, this is just utility classes, utility methods that never change, like calculating, what would be the day in 5 years' time, things like that. Just everything depends on it. They won't change, and then they don't know anything about the rest of the application. And on top of it, we have this domain layer. So domain layer is where we keep our domain objects, basically. So for our bet app, we have all this like bet data classes. So bet is a bet, isn't it? It doesn't change. Or a horse race is a horse race, like horses race, they run. I mean, there's nothing that you can change about it. It's just the business. If it changes, it means that you are changing your business anyway. So that's stable, and it just depends on this util, nothing else, and it doesn't know anything about data. And then data is like one level less stable, isn't it? It may change, it does change, but still like not as much as domain. And then the application is a top layer. It depends on all of it, and it changes, isn't it? Like the input method, for example, you are using it on a mobile phone. So I mean, people touch and then people do stuff. Then your boss then comes and say that, what, the product owner, just we got a deal, and then we want to make this application to run on a tablet. I mean, that happens all the time, right? I mean, in some of the companies that I worked for, I even remember saying that it's not possible, and that the code was so tightly coupled that I couldn't even merge. I couldn't even just commit to, to changing it from phone to tablet. I mean, it just didn't work. I mean, it happens. Cool. So there are some other ways, obviously. Clean architecture is one way to design it. The SOLID is a acronym. I mean, probably you all know it. It's just 5 principles to ensure a proper design. I won't go details on each of them, but these are the principles that help us to keep our code base tidy. So we already talked about dependency inversion. Single responsibility, for example, is about, it still serves the same purpose. Like it says that there must be only one and only one reason to change a class. It shouldn't do or be responsible for more than one thing. So one class does one thing. If you need to change it, it should be only for one reason, right? Just separate it. If it's doing more than one thing, just separate it, write tests against it, and hopefully it when time comes to change, it will be small. Design patterns. So when it comes to choosing a particular architectural design pattern on Android, we have like several options. So these are just the ways to implement the principles that we discussed. So you can go anyway, if you ask me. Like you probably heard these fancy design patterns we use when building an Android app. So design pattern is an implementation approach we choose to achieve our goal, like separation of concerns. So although some of these are more popular than the others, fundamentally they all try to achieve the same thing. So therefore, I will dare to say that it doesn't matter that much which way you go. It's all about the same thing. So what I'm trying to say is like tools and patterns change, but principles are there. For example, MVVM and MVI is the most popular thing now. They're popular, but 5 years ago, it was all about MVP. I mean, if you just check job specs, you'll see MVP all everywhere. Then 10 years ago, it was even MVC. Well, 15 years ago, we didn't even have any of these problems, on at least for Android. So what specifically Android has to offer us, just to build, just these apps to last? I mean, obviously, they don't dictate or insist any particular pattern, but implementing some of them, just seems easier than the others. So MVVM is sort of advocated now, I believe. And then there are view models, coroutines, live data, and some other patterns, just recommended. But again, all it comes to one point, as you can see here, I just took this from the official Android web page. It's all about separation of concerns. Even they don't mind that much how you achieve that. They provide some tools, but this is what you do basically. And I'll just show you one example. So this is, again, probably you saw it, and this is from Android's official website. I won't go into details of each layer, but here just to show you that, all Android guys at Google try to do the same thing. So live data here, I would like to talk a bit. It's a mechanism to help, just keep our Android activity and fragments here at top as free and dummy as possible. So the less they know about the rest of the application, the better. So with live data, now as developers, we don't need to worry much about the life cycles of just activities and fragments here. When years ago, that was a big headache for us, like handling the change in the life cycle of these activities. Like just when user rotates the screen, all these classes would be recreated, and it just affects the rest of the application because you need to handle this life cycle. But this live data, what they did is this live data notifies just the change in the rest of the application only when there's an activity that's listening to it. I mean, how it used to work, like when you rotate the screen, for example, since they are just recreated, you wouldn't have an activity to update. So, I mean, just very typical scenarios like that. Like imagine you click a button, you are getting the odds, right, for a bet, say, or any kind of data. So you make the call, then before the data just comes, right, you just rotate the screen, and then your activity, your screen is basically gone. But the data arrived, and then you want to show it to user, and it would just crash. I mean, like 50–60% of the crash like years ago, that was the one single reason. I mean, it's not like that anymore because we have this live data. It's just like these layers are basically separated. So it's better now. So I have some books to recommend. So we talked about the technical principles, but obviously the code quality and building apps to last is a wider subject that requires everyone's input in the team. I mean, it's the product owner, your colleagues, the CEO, they should all just like aware of this, right? I mean, if I just say they should all have this right mindset. So therefore I would just suggest you and everyone else to basically to read these books. There's even another one, Clean Agile, I think, for agile processes. So that would probably be the best investment ever, like in terms of ROI, where you and you or your company just spends £100, but potentially save thousands, if not millions. I mean, I just give this book as a gift to probably like everyone in management that I work for. So just one example, this Clean Coder book, it talks about the human side of the things. Yeah, so like as a developer, you may not know, or maybe you know, but it's just like you should know how or when to say no. It's like not pushing back is a big issue. Like it's not pushing back the toxic requirements is a sure way to kill app or business. So it's not only, I'm trying to say that it's not only just technical, it's just there's human side as well. So these books really help. So that's it really. Thanks for your time again. So I can answer some questions, I guess. So if you have more questions later on, please feel free to get in touch on LinkedIn later. Thank you.
Cheers, mate. Thanks for the talk. Yeah, as we said, guys, if anyone's got any questions, if we can put that in the chat box, that'd be great. And yeah, like I said, like we normally do, if we can put the questions in the chat box, that'd be perfect. Just wait to see if we get any.
How can I see the chat box?
Chat box should be at the bottom of the screen.
I'm just stopping sharing my screen. Maybe then I will see it.
Yeah. Can you see it now? It's there's one saying, "What do you think about package by feature?" See that now?
Okay, yeah, I can see it now.
Oh.
What do you think about package by feature? Can I just click on this link and see package by feature? Well,
yeah, what I'm trying to illustrate that if you see the diagram, it's easier to understand it. Basically, if you go with the data controller, entities, all that package structure,
yep.
maybe use models as well, modules as well.
Yep.
At some point, it's not easy to maintain that code, because when you have to add something new, you have to remember that you have to add one to each of the modules, right?
Mm-hmm.
And what this guy is suggesting is that maybe you can just add like a feature, a new package or module per feature, so that with that you know that you have to add one new module or one new package and have all those same things there. And if you have to change something related to that entity, you know that you have to do all the changes there and not touch anything else.
Well, yeah, okay, I think I got the idea. I mean, I didn't obviously read all the page, but I think that's what we are doing per module. Like, I mean, if it's like the domain or data module, that would like work. That's pretty much what we are doing anyway, like the entities and then, you know, the details like stay together. But when it's a different module, like app module, probably we are just designing it in a way that just business related classes stay together rather than, you know, just technically close. If you see what I mean. So in our application, for example, in betting application, so the races, anything about racing just stays in the same place, but in the app module, but in the data module and domain module, and what you're saying makes sense. I mean, because they are not business related, you are going away from business, then you will have more flexibility of like technically, you know, just taking a technical decision to, you know, just keep them together. So yeah, that makes sense.
Perfect. And yeah, I think there's one more from Harsh. Thank you. What was your testing strategy?
Okay. Thanks for the presentation. What's your testing strategy? I mean, testing could be the next talk, actually, Tom. I mean,
okay.
It's a very big. I mean, this is a vast subject, isn't it? The testing strategy. What we do, like, we do it at several different levels, obviously. Well, if you're asking how it's related to what I just presented, to make it testable, to, you know, just to make your architecture testable, we start with TDD really, and this TDD ensures that, you know, just you have a testable like code base, because like from the point that you start writing it, you write in a way that, you know, just is separated so that you can test modules separately. So we start with the unit test, then we obviously have our integration test, like at some point manual tests, and then the, you know, just espresso test as well, like test the UI, the automated test. So it's just several different tests at different levels. But yeah, I mean, that just goes hand in hand really. And just if we have the proper architecture designed, then testing will be much easier. That was another reason why all this application I worked on wrote really, because you couldn't test it. I mean, I'm asked to make, I seriously remember being asked to change something little on one screen. I just couldn't, because there was no way to ensure that I don't break anything if I just make the change. So I just say that, just I can't change this because it will break. I mean, you change something, it will break because the test is not there. You can't write test because the architecture doesn't allow it. So it just goes hand in hand, I believe.
That makes sense, yeah.
I'll just check the last one. What's your experience of improving a legacy app's architecture to be maintainable rather than throwing it away and starting over? And that happens all the time and everywhere, really. And just when I join, I'm a bit unlucky, to be honest. I mean, only in one case, I just joined in the new team, just to develop the app from scratch. So that was great, but this is just a big luxury. So what we do is when I'm given the legacy app, obviously I try to write unit tests. I say that, just to set your expectations properly, I won't be able to add any new feature or I won't be able to provide some business value. So I need some time to write some unit tests, at least in some important areas, so that when I make a change, I have the, just confidence that I'm not breaking anything else. So that would be my approach. I just go through the code, I just see, just code coverage, and then I come up with a report saying that I need that much time or just mandate to write this much test, so that after that we can start, just building something on top of it, right? Otherwise it's just gambling. You can make a change in 2 days, 2 hours, then who knows? So that's the strategy for a legacy app.
I think there were two above Douglas's questions. There's one from Matt Brooks and Mark.
From Mark, Matt Brooks, okay. Would you separate the module even further by using separate repos and using Gradle to include them? Repos, I mean, it depends really. I mean, just what we do, I'll tell you what we do. I mean, the repos, we have separate repos if we are getting data from different providers. So you can imagine one repo per provider. So if you have one endpoint, right, the internal endpoint, so then we have one repo to get data from there. But if you have a really big project, then you can just maybe put a hierarchy of repos to just separate it by business. Probably maybe in BetStep again, if we don't have that many endpoints, but if we had, we could just say that, okay, this repository only for races, this repository only for football. Then you could have a hierarchy there. But I would say keep it simple. I would just start with one repo, then just keep adding more if you feel like you want more. And there's no one certain rule for it, obviously. That's what I would say. So Mark, you mentioned Coin earlier as a third-party product tool. What's your view about dependency on third-party component regard? So the Coin, this third-party tool, I really like it. I wouldn't just talk to the just developer. I appreciate, admire them, but I don't use these in any commercial applications that I join any team. And the reason being, you can't vouch for anyone. I'm using it for my all personal projects. But if it's a big commercial application, I go with what Google has and suggests, which is Hilt. So yeah, I try not to use third-party components unless they are just proven to be just stable and supported. So, but my first reaction is not don't use it. I don't want to take any risk if possible. Is there anything else?
I think that looks like it's it from the questions, looking at the chat box, mate. But yeah, no, I think that is looking like that. That's the question. So thanks for everyone for sort of doing that. And thanks to yourself for obviously speaking today. Really appreciate you taking the time out to get the presentation sorted. Yeah, guys, thanks for attending. Yeah, keep in touch. We do have another presentation coming up next week. So that'll be on the meetup group tomorrow. But guys, thanks again. All take care. Enjoy the weather. And yeah, we'll speak soon.